To understand the fate of our home, we must first understand the most fundamental rule of the universe. Everything is moving away from everything else. In 1929, the legendary astronomer Edwin Hubble looked through his telescope at Mount Wilson and shattered our perception of reality. He discovered that the galaxies scattered across the dark void were not sitting still. They were rushing away from us, and the farther away they were, the faster they were fleeing. This was the discovery of the expanding universe. It led us to the realization that space itself is stretching, like a balloon being inflated, carrying galaxies along with it like dust motes on the surface. For nearly a century, this has been the bedrock of cosmology. We know that a mysterious force, which we call dark energy, is pushing the cosmos apart, stretching the fabric of space-time faster than the speed of light in the deepest reaches of the void. Logic dictates that in such a universe, isolation is inevitable. Every object should eventually drift away into the lonely darkness. But if you look just outside our own back door, at our massive neighbour, the Andromeda Galaxy, you will find something that violates this rule. While almost every other galaxy in the universe displays a redshift, meaning their light is stretched as they move away, Andromeda displays a blue shift. This is a warning signal. It means it is not moving away, it is charging towards us. Right now, as you watch this video, the colossal Andromeda Galaxy, containing 1 trillion stars, is hurtling through the void directly at the Milky Way. It is moving at a terrifying speed of 110 kilometers per second, about 68 miles per second. That is fast enough to travel from the Earth to the Moon in under an hour. This creates a massive cognitive dissonance. It creates a paradox that confuses students and laypeople alike. How can 2 contradictory truths exist at the same time? Truth number 1, the universe is expanding and space is pushing everything apart. Truth number 2, our galaxy and Andromeda are crashing together in a gravitational suicide pact. Is the theory of the Big Bang wrong? Is dark energy failing? Or is there a different, more primal war being fought in the dark, a war between the expansion of the void and the iron grip of gravity? To solve this puzzle, we have to look at the battlefield not as a static painting, but as a dynamic struggle between the 2 greatest forces in nature. To understand this struggle, we must step onto the battlefield itself and examine the rules that govern it. At first glance, it may seem as though the universe should have chosen a single winner long ago. Either gravity should have pulled everything together, or dark energy should have torn everything apart beyond recognition. But the cosmos does not operate on simple absolutes. Instead, it obeys a far more elegant and nuanced law. Distance determines dominance. On small scales, on the scale of planets, stars, and even entire galaxies, gravity is king. It is ancient, relentless, and profoundly intimate. Gravity thrives where matter is close enough to feel its pull. Within these regions, dark energy is essentially powerless. Your body doesn't expand. The solar system doesn't expand. Even the Milky Way itself remains tightly bound, untouched by the stretching of space. Here, gravity's grip is absolute. But move farther out, far beyond the edges of galaxies, into the silent, starless void, and the rules change completely. Out there, the distances between objects become so vast, so mind-bendingly large, that even the tiniest amount of dark energy starts to outweigh gravity's influence. And in those vast stretches, expansion wins, space stretches, galaxies drift apart. Light itself is pulled into longer, redder wavelengths as the fabric of reality grows beneath it. This is why almost every galaxy in the observable universe appears to be fleeing from us, not because we are special, but because the space between us is growing. The expansion is not pushing galaxies away like debris from an explosion. It is creating more space between them. And yet, within this grand cosmic tug-of-war, some regions defy the trend entirely. Places where gravity has gathered enough mass, enough structure, enough momentum to push back against the growing void. These are pockets where the universe refuses to drift apart, where matter holds itself together despite the accelerating expansion. Our local group is one of those pockets. The Milky Way and Andromeda are not following the flow of the expanding universe. They are locked in a gravitational embrace so deep, so ancient, that even dark energy cannot loosen it. Their fates were sealed long before humanity ever looked up at the night sky. This is the true rule of engagement between gravity and dark energy. At small distances, gravity conquers. At large distances, expansion dominates. And where the two forces meet, the destiny of galaxies is decided. To understand why our galaxy is on a collision course with Andromeda, we must first examine the cosmic neighbourhood we call the local group. This is not a mere collection of galaxies drifting randomly through space. It is a gravitationally bound community, held together by invisible threads of mass and momentum. Within this group, distances are short enough and gravity strong enough that the relentless expansion of the universe cannot pull its members apart. The Milky Way, Andromeda, and dozens of smaller galaxies are all participants in a delicate cosmic dance, moving along paths dictated by the combined pull of billions of stars and vast clouds of dark matter. Gravity here acts like an invisible glue, weaving together the fates of galaxies that might otherwise have been isolated in the void. It is a force both patient and persistent, shaping trajectories over billions of years with an elegance that borders on the poetic. The Milky Way and Andromeda, our two largest neighbours, are the most prominent partners in this intricate ballet. Their mutual attraction is so strong that it overwhelms the universe's expansion on this scale, ensuring that they will inevitably collide in a spectacular merger several billion years from now. But the local group is more than just a stage for two galactic giants. It is a testament to the subtle balance between cosmic forces. Regions where gravity has concentrated mass, forming resilient pockets that defy the growing void. Even the smaller satellite galaxies are bound in this web, their motions tracing the contours of an invisible gravitational map. Observing the local group is like peering into a miniature universe, a place where the rules of the cosmos manifest in concentrated form, revealing both the power of gravity and the limits of dark energy. In the end, the local group reminds us that while the universe is expanding, not every region is fated to drift into isolation. Some neighbourhoods, like ours, remain tightly knit by the invisible bonds of gravity, destined for encounters and mergers that will shape the future of galaxies for eons to come. In about 4.5 billion years, the cosmic ballet between the Milky Way and Andromeda will reach its spectacular climax. The two galaxies, each containing hundreds of billions of stars, will begin to merge in a slow, titanic dance. Despite their immense numbers, individual stars are unlikely to collide directly. The vast distances between them are far too great. Instead, the gravitational interplay will reshape the galaxy's structures, sending streams of stars arcing into space and igniting bursts of star formation as clouds of gas compress. From the perspective of any future observer within the merging system, the sky will be transformed into a dazzling spectacle. Swirling ribbons of starlight, shimmering nebulae, and the slow, inexorable blending of two galactic giants. Eventually, the Milky Way and Andromeda will fuse into a single enormous elliptical galaxy, a new cosmic entity that astronomers have already begun to call Milkdromeda. This merger is not an abrupt collision, but a gradual, majestic transformation, a reminder of the dynamic, ever-evolving nature of our universe. Billions of years from now, the universe will have expanded to a point where the cosmic tapestry around us becomes nearly empty. The remnants of countless galaxies, once clustered in intricate webs of matter, will have drifted beyond the reach of observation. Our merged galaxy, Milkdromeda, will remain a solitary island in the vast, ever-stretching void. Its billions of stars will shine like a lighthouse in darkness, a testament to the tenacity of gravity amidst the inexorable pull of cosmic expansion. From its core, supermassive black holes will continue their silent reign, bending light and warping space-time, while distant stars slowly age and die, leaving behind ghostly remnants of what once was. The sky itself will transform into a serene yet haunting panorama. Nebulae will fade, star clusters will thin, and the faint glow of the cosmic microwave background will be one of the few remaining witnesses to the universe's ancient birth. Light from other galaxies, stretched to unobservable wavelengths, will no longer reach Milkdromeda, isolating it in a sea of darkness. Any observer within this lonely galaxy would experience a profound sense of cosmic solitude, a silent reminder of both the vastness of the universe and the ephemeral nature of its contents. Yet, within this isolation lies a quiet majesty. Milkdromeda will endure, a single luminous node in an ocean of darkness, shaped by the eternal struggle between gravity and the expanding void. Its stars will continue to orbit, new stars may still form, and black holes will dance in the shadows, silently marking the passage of eons. In this ultimate solitude, the universe's story becomes both intimate and infinite, a testament to the beauty and melancholy of existence, and a final reminder that even in the farthest reaches of time and space, structure and meaning can persist against the tide of emptiness.